Welcome to my classroom. The problem in this video expects some knowledge about circles. So it is good for Form 5 students after learning the topic of properties of circles. An archaeologist found a piece of broken plate. He wants to know the diameter of the plate so that he can reconstruct the plate with other pieces and materials. Can you help him? A plate is essentially a circle. A circle is determined by its center and radius. When the location of the center is known, it is easy to find the radius by measuring the distance between the center and any point on the circumference. So once the radius is known, the diameter is obtained by doubling the value of the radius. In other words, the problem can be rephrased as: find the center of a given circle or a part of a circle. See if you can provide more than one method to find the center of a given circle. Pause and think. The first method is done by geometric construction and the chord property. The method can be applied to a part of a circle. For the sake of easy drawing, I use a whole circle here. First, take any 2 points on the circumference to form a chord. Here, AB is the chord drawn. Then, construct the midpoint of AB, say M. Then, construct the perpendicular to AB at M. So the line construct is the perpendicular bisector of AB. According to the chord property, that perpendicular bisector of chord passes through center. That is, the center lies on the perpendicular bisector construct. Yet, there are infinitely many points lying on the perpendicular. So we need to construct one more perpendicular bisector to fix the location of the center. Repeat the construction similarly. Draw a chord CD. Construct the midpoint end, and construct the perpendicular bisector of CD. The two perpendicular bisectors intersect at a point. Since the center lies on both perpendicular bisectors, the intersection point is the center of the circle. Now, the center is found. Measure the distance between the center and any point on the circumference to get the radius. Multiply the result by 2 to get the diameter of the circle. The task is done. There is another construction method which is even quicker, but the requirement is that the broken plate or the part of the circle is greater than a half. Here is the construction. Like method 1, we draw a chord, say AB. Construct the perpendicular to the chord at an endpoint, say B. The perpendicular meets the circumference at C. If the broken plate is too small, smaller than a half of a plate, then C cannot be identified by such construction. By the property that the converse of angle in a semicircle, we know that AC is a diameter of the circle. Therefore, the midpoint of AC gives the center of the circle. So, the center is found. There is other type of method involving more measurement and calculation. I demonstrate one of this type here. Draw a chord AB and mark the midpoint M. Construct the perpendicular to AB at M, meeting the circumference at C. That is, the line CM is the perpendicular bisector of chord AB. Denote the distance of AM by A and CM by D. Measure the values of A and D. That is, they are known value now. Although we don't know where is the center yet, let us denote the center by O and mark it roughly in the diagram for further consideration. Denote the radius by R. We don't know the location of the center, and thus R is an unknown. Considering the triangle OAM, as OC perpendicular to AB, angle OMA is a right angle. By Pythagoras' theorem, we can connect the square of the three sides as r squared equals to r minus d squared plus a squared. This is a quadratic equation in R. Solve the equation for the radius. Then, not only the diameter is found, but also the location of the center. The construction in the previous method can be done by ruler and protractor, which make the construction easy. In fact, all the construction in these methods can be done by straight edge, that is, ruler without measurement, and compasses only. Such geometric construction has been learned in junior form. Can you recall how to use straight edge and compasses to construct midpoints and perpendicular to a line at a point? Actually, we also learned how to copy an angle, bisect an angle, construct a line parallel to another line, etc. Do you still remember how to do that? It is interesting not only to do the construction, but also prove why it works. Please try. I have demonstrated 3 methods of finding the center of a given circle. In fact, there are more methods with different construction, measurement, and calculation. I have 3 more. How about you?